Hello dear students, I Abhinav Negi welcome you all civil engineering and mechanical engineering students in the first session, the first technical session of GATE 2025 guys. So guys, from today guys, the foundation batch or the foundation course is started. Okay, and first of all guys, we will be going with the strength of material guys. Okay, so today I'll be telling you about stress and strain, all concepts, derivation, types of normal stress, types of shear stress guys, normal strain, shear strain, derivation plus numericals. So guys, please watch this session till the end to get the complete knowledge of normal stress, shear stress, normal strain, shear strain, their types and sign conventions, derivations plus numericals. Okay, so guys, moving forward, I hope all of you are doing fantastic guys. So this is about me. Those the students who are not knowing me, my name is Abhinav Negi, having 12 plus years of teaching experience. Done my MTech from IIT Delhi, got All India rank 164 in 2012. You have to score better rank than this. And this is my email ID and my Telegram group is Civil by Abhinav sir. Okay, already guys, more than 6,000 students have joined here. Okay, so you can also join in my Telegram group Civil by Abhinav sir, where I'll be providing the PDFs, updates, complete schedule as well. Okay, so this is the foundation course guys for civil and mechanical both, and this is the guys schedule. Okay, so first guys, today is this class. Okay, yesterday I have told you about the weightage, me and Dheeraj sir have told you about the weightage syllabus, how many marks the strength of material comes in GATE and ESE all. Okay, so stress, I'll be telling stress and strain basics, then deformation of bars, stress strain diagram will be done by Dheeraj sir, then properties of material, then environment will be there, and then fluid mechanics will be there. Of course guys, in this session SOM will not be completed. Obviously in this session environment will not be completed, and so as fluid mechanics. Let me tell you guys, this is the schedule of March. Of course guys, in the next months we have other classes as well. Similarly guys, here SOM as you are seeing right now, then it will be thermodynamics by Vipin sir, and then fluid mechanics by Chandra sir. Okay, this is the schedule of March guys. Of course in April I'll be showing you the schedule soon. Okay, you can join the workshop if you want to know about the GATE 2025. This workshop is on 13th of March at 7:30 PM on app. Okay, so if you want the strategy, for GATE 2025, you can join this free workshop. And if you want to enroll in Byjus guys, then on 14th of April there is a scholarship test on app. You can enroll in that scholarship test for free of cost and get the discounts. Ground Zero series is running on app also, where at 5:30 PM I am teaching highway engineering. Okay, at 4:30 PM SOM is going on. So those free classes you can join app as well. Okay guys, if you want the complete course, okay, classes, doubt solutions, test series, ebooks and everything, then the courses are Vision 2025 and 26. The courses are available in English and Hindi both. You can join the batches and get the complete course. To know anything about these batches, fees, study plan, duration, guys, you can either connect to this number, or in the description box there is a Google form. You can fill that to have a one-to-one counseling. To know anything about this course, you can call there guys. Okay, ready everyone guys? Please put a heart sign for the first session of strength of materials. Everybody on the comment section, how is the Josh guys? Everyone, please tell me, how is the Josh, my champions? How is the Josh? Okay, shall we start the session guys? Stress and strain. Yes, please share the session to all guys. Before coming to stress and strain guys, what is SOM? Okay guys, suppose this is a body. In this body I apply any number of forces, 1, 2, 10, 20, 50, any number of forces in any magnitude, in any direction, any number of forces with any magnitude, with any direction. If the relative displacement of 2 points A and B is not changing, it is as it is, by applying any number of force, any direction, any magnitude, if these points are as it is, not coming closer, not moving apart, okay, they are as it is, not the orientation is changing, it is considered to be a rigid body. And if by application of forces they come closer, move apart, or orientation is changed, that is a deformable body. In actual, every body in this universe is a deformable body. Yes, that deformation is not very small, not visible by naked eyes. SOM is dealing with deformable bodies, whereas engineering mechanics, your class 11th physics, is dealing with rigid body. When you are studying engineering mechanics 11th and 12th physics, then a body is considered to be rigid. That means the dimensions will not be changed, the shape will not be changed. But in strength of material, We are dealing with the real physics now, guys, and the real body is deformable body. Okay, there is rigid body is just an assumption. Okay, rigid body is just an assumption. In reality, only deformable body exists in this universe. Now in strength of material, guys, we will be studying about the internal forces. What are those internal forces, sir? I'll tell you. Okay, in engineering mechanics you study about the external forces. Sir, what is internal force? Sir, what is external force? I'll tell you. So guys, in SOM it is deformable body, है ना? Length will be compressed. Okay, deformable body we study. Okay, and guys, rigid body can go, suppose this is a rigid body, na? So rigid body can go here. Okay, rigid body, that body you can put from here to here, that body you can put from here to here. Okay, that body can change its position, but inside a body the points will not be coming closer or moving apart or changing the orientation. A rigid body, if you are assuming a body to be rigid body, then it can go from here to here, it can go from here to here, but dimensions and orientations will not be changing. Now guys, what are internal forces, what are external forces, what are normal stress, everything I will be telling you. Okay, so ready guys, from here the classes is going to start. Yes, Rotela Saab, good evening. Ready, everyone guys, come on. Come on. Ready? Okay. What is normal stress? I'll tell you guys, don't worry. Suppose this is a bar. Twing. You apply a P force here and you apply a P force here. Okay, and leave. Let me make another one. Okay, so guys, suppose it is a bar here and in this bar you apply a P force. So from here fixed support, a P reaction will be coming. Now this is external force that you are applying, by a human is applying or a machine is applying. You are applying that force externally, or reactions. Okay, you are applying that force externally. Somebody is applying that force. You have put some weight. That is external force. You have applied on that body. Okay, you have applied that force on the body. That is external force. Guys, acceleration will be zero because net force is zero, na? So acceleration is zero. If this is a rigid body, if rigid body, then what will be the deformation? If this is rigid body, then deformation is zero. Okay, got it, sir. But in strength of materials, we assume a deformable body. If deformable body, then there will be some deformation. Then there will be some deformation and there will be some elongation or contraction or shape changes. Okay, so here will be a deformation because delta is the deformation, because it is deformable bodies. In SOM we study about the deformable body. Okay, Kannakanti, Kitali, everyone. Okay, you can ask me a doubt as well in between. This is a deformable body, so here the deformation will be there. Okay, now usually when I call stress, then this normal stress is represented by sigma, and student says stress is equal to the force you have applied divided by the cross section area. This usually students call, sir, this is the stress. Let me tell you, this is absolutely wrong. This is not stress. This is not stress, not normal stress. You say it is force by area, that is absolutely wrong. Let me tell you the real picture of stress, everyone. Suppose this is a body, and in this body I cut a section from somewhere between XX. Name this as one part and name this as two part. Okay, I'm cutting the body now. Okay, sir, got it, sir. So here is one part and here is another part. This is part 1 and this is part 2. This is part 1 and that is part 2. Now what are the forces? I want to draw the free body diagram, guys, and please look it very carefully. Here is the P body, P force. So apply the P force here. Here the P reaction, so here the P reaction. Now listen my each and every word very carefully, guys. Each and every word very carefully, everyone, guys. Okay, in between if you have any doubt you can ask me as well. Okay, now this whole body is in equilibrium. P downward, P upward, net force is 0. So small part will also be in equilibrium. If I am in equilibrium, my nose is also in equilibrium. It is not going to Khandala. If I am in equilibrium, my specs is also in equilibrium. So if this is in equilibrium, this part will also be in equilibrium. Now it is not in equilibrium right now. If this is the force, then P will move it upward. If this is the body, P will move it downward. So guys, this whole body is in equilibrium. So small part must be in equilibrium. So guys, to make it in equilibrium, here the P force is coming. And to make this in equilibrium, here the P force is coming. This is internal force. This blue color, usually if you study SOM from me, I will be making the external forces with blue color. Okay, sorry. These are the internal forces. These are the internal forces that I am making with the blue color. Okay, internal forces. And guys, internal forces in nuclear body will always be equal in magnitude. P downward, P upward, both same. P downward, P upward, both same. Internal force are always equal in magnitude and opposite in direction. One upward, one downward. Okay, for equilibrium body, if you cut the section and you find the internal forces, it will be equal in magnitude. One upward, one downward. Equal in magnitude, PP, and opposite in direction. Actually, the normal stress is the resistance of force, and that is given by, the stress is given by internal force per unit area. Internal force per unit area, and normal means perpendicular to the section. Normal means that force P, I am talking about this cross section. For this cross section, this internal forces are perpendicular. So perpendicular internal force by area is normal stress. Guys, now you will say, sir, you are saying that this is correct, this is wrong, but answer will be same, na sir? Answer will be same, na sir? Yes, guys, answer will be same. But if I don't tell you this concept, and only you understood this concept, then if I ask you a question that here is a surface where coefficient of friction is assumed to be 0, and here is a body, and here I am applying a P force, then if I don't tell you this concept, you will be saying, sir, stress is equal to, in this perpendicular cross section, in this cross section, you will be saying stress is force by area. You will be saying stress is force by area, P by A. No, guys, stress will not be coming here. If I have not taught you this, you only know this, then you will be saying stress is P by A. No, guys, stress is 0. Here it will be accelerating, guys, by force by mass. Listen to me. Stress is internal force by area, na? Now, if I cut a cross section here, and name it one part, then here is the P. Then, guys, here I made the internal force because whole body is in equilibrium. So, to make it in equilibrium, P downward coming internal force. To whole body in equilibrium, for making this equilibrium, for this P external downward, P internal upward should be coming. But, guys, here, why I will be making it P here? If I am making P here, that means I want to say that it is in equilibrium. No, it is moving with P force. It is not in equilibrium. So why to make here internal force? Internal force will be 0 here. So 0 by area will be 0. Here, guys, acceleration will be 0, but stress will be P by A. Here, acceleration will be P by mass, but stress will be 0. One more thing very important here, guys. This is actually, many of the teachers are not telling this, but let me tell you that if this is a body and here you apply external force P, here you external force P, at any cross section, whether here, at any cross section you cut it like this, you will be getting internal force P. So you will be writing the stress is equal to internal force by area. Okay, that is correct, but it is not actual. It is not actual. Even this value is also not the actual stress. Because guys, at the point where point load is acting, at this point where point load is acting, stress will be more, and far away point stress will be less. So guys, for a particular distance up to this point, stress is varying very significantly. Yes, after some distance, when you reach here, not very close to P, but here in these whole sections, stress is P by A. But very near to the point load, actually stress is not. Like if you don't take this green section, and if you take this purple section, stress is not P by A at every section. Okay, at inside stress is more, but at far away point stress is less. So very near to point load, stress is not constant P by A. Yes, but a certain distance away, stress is P by A. Okay, sir. This is a normal stress. We have some other stresses as well. Now, one more thing. In actual practice, when I cut this one point, okay, I make this internal force P, but in actual, there is a whole cross section, na? So there are, when I cut this one body, here, I make only one internal force P. Okay, but this body is attached to the second body by not at one point, but various points, na? So there are various resistance coming. The various resistance are coming, guys. And summation of all that small p is equal to capital P. The stresses are, internal force are coming at all points, and summation of all those points are capital P to make it balanced. Everybody on the comment section. Everybody on the comment section. Have you understood the complete logic? Yes or no? Give me yes or no, guys, on the comment section. Give me yes or no. Everyone, guys, come on. Tell me. Have you understood? Have you understood? Put a heart sign, guys. Come on. Okay. So you have understood. Good. Now moving further, guys, we'll be doing so many things here. Okay, so stress is coming at all points, when summation of all those points are such that to make it in equilibrium. Okay, so there's tensile stress, which tries to elongate the body, and compressive stress, which tries to contract the body. Okay, now strain will also come, don't worry, strain will come, don't worry. Okay, now guys, shear stress is represented by Greek letter tau. Normal stress was perpendicular. This is tangential internal force. This is tangential internal force by area. Now, sir, please give us an example of this as well. Sir, please give us an example of this as well. See, suppose this is a beam. In this beam, exactly at the center, a P load is coming. So here are the column, and as it is symmetry, so column will be applying a load 0.5 P and 0.5 P. Okay, sir, no doubt, sir. Now, if I cut a cross section, this green cross section XX, and name this as one part and name this as two part. Okay, sir, got it, sir. Now, this is a one part. Okay, this is one part and this is a second part. Okay, this is one part, this is second part, and here 0.5 P external force is reaction I am considering to be external force. Here is also 0.5 P and P is coming here. Guys, I am only considering force equilibrium right now. Only checking force equilibrium. Only considering force equilibrium. Moment equilibrium I am ignoring right now. Okay. Whole body here is in equilibrium. Force equilibrium. So here also it has to be in equilibrium. Okay, if whole body here is in equilibrium, so here this one also has to be in equilibrium. So here 0.5 p upward, so here it will be 0.5 p downward. Of course a movement will be coming, but that I am not showing right now. Okay, because if this is the case, then it will rotate, but movement equilibrium I am not showing. Similarly, p downward for whole body is in equilibrium, so small part is also in equilibrium. So p downward, 0.5 p upward. So from here 0.5 p upward is coming. Okay, internal force again, once again guys, you can see it is equal in magnitude. 0.5 p, 0.5 p, 0.5 p, 0.5 p, 0.5 p, 0.5 p. It is equal in magnitude and opposite in direction. One is downward, one is upward, one is downward, one is upward. And on this area, please see this area. On this area, guys, on this area, this is normal stress or shear stress? This is tangential or perpendicular? On this orange area, that is shear stress, tangential stress. So shear stress is equal to that internal force, the tangential internal force 0.5 p, the tangential internal force 0.5 p divided by that area. Okay, so this is shear stress. This is shear stress, guys. Okay, 0.5 p. It can be 0.5 p or 2 p or 100 p or 2000 p, any p, divided by area. That is shear stress. Got it, sir? Any doubt you can ask me? Kitali and everyone. Kanakanti, Ajmeera, any doubt? Any doubt, guys? Okay. This is shear stress. Normal stress you understood. Normal force by area. And shear stress also you understood. Okay, sir. Now my question to you, strain I will be coming. Don't worry about that. Strain I will be coming. See, now my question is, suppose this is a body resting on the floor, and in this body I am applying a P force like this. Now my question is, everyone please answer this question. On this body normal stress is coming or shear stress is coming? On this body normal stress is coming or shear stress is coming? Everybody please answer on the comment box. Normal stress is coming or shear stress is coming, or shear stress is coming? Tell me, guys. Everyone on the comment box. Vishnu Pandey is saying normal stress. Okay, others. Vishnu, I have no idea for that. Shear stress. Rishabh is saying shear stress. Vishnu is saying normal stress. Guys, everyone, answer is both will come. Answer is both the stresses will be coming, guys. That depends on plane. Okay, that depends on plane. If you cut this plane, of course guys, P is the force. If you see externally, so here the reaction will be P. Now if this exact section you cut, okay, again you cut the body, internal force, same concept, same story. So sigma xx is P by A, because P will be perpendicular on that, and there is no component of P tangential to that. No component of P tangential to that. So shear stress will be 0. But if I am not taking this xx plane, instead I am taking this yy plane. Instead I am taking this yy plane. In this yy plane, if this is the P force, then guys, one component will be P1 of this. P is the father, na? So this father will be having two sons, two components, P1 and P2. P1 and P2. Now on the yy plane, sigma yy is equal to P1, of course that will be internal force, P1 upon area of that plane, A dash I am saying, and shear stress on YY plane, and shear stress on YY plane is equal to P2. P2 is causing, P1 is normal to that and P2 is tangential to that. P2 by A dash. Okay, normal stress on YY plane is P1 by A dash and shear stress is P2 by A dash. Okay, so guys, both will come. That depends actually on plane. That depends actually on plane. There are infinite planes in this body. There are infinite planes in this body, guys. Infinite planes will be having, how many planes will be there, guys? How many planes? One plane, this. Infinite planes will be coming. Infinite planes will be coming. Infinite planes will be having infinite different normal stresses and infinite different shear stresses. Infinite planes will be having infinite different normal stresses and infinite different shear stresses. That at 30 degree plane, 40 degree plane, 50 degree plane, 52 degree plane, 56 degree plane, at different plane, what will be the normal stresses and shear stresses that we see in stress transformation chapter, or you someone call it principal stress chapter or you more circle chapter, whatever. At different planes, what will be the stresses that we'll see in chapter number 4 or 5. Okay, have you got it now? Everybody please put a heart sign on the comment box if you got it, guys. Come on, everyone, got it? Okay, so this will be coming. Now my question is, can I ask you an interesting fact, guys? Normal stress, you see, stress is of two types. Okay, normal stress and shear stress. Again, the normal stress will be having various types, guys, direct, that we'll see in some other class. Okay, normal stress will be bending stresses, okay, bearing stresses, compressive stresses. Shear stress will also be, let us see in this class only. Okay, let us see in this class only. Shear stress has two types. Okay, shear stress has two types, direct shear stress and indirect shear stress. Normal stress is three types: compressive, bearing and bending. But leave about the types of normal stress and types of shear stress. I've been telling you in just a couple of minutes. I want to ask you a question. Is this a vector? Stress is a vector or a scalar? Tell me in the comment box, because this has magnitude, na? Force by area. Normal stress is normal internal force by area. Shear stress is shear internal force by area. That has magnitude. Okay, and that has direction also. Normal is perpendicular, shear is tangential. So is this a scalar or vector? Stress is scalar or vector? Tell me. Tell me, guys. Stress is scalar or vector? Everyone. Come on, Rishabh, Vishnu, Karnakanthi, Ajmira, Pandey, everyone. Is scalar or vector? Guys, stress is having magnitude and direction also. Normal stress is perpendicular, shear stress is tangential. Normal stress is perpendicular, shear stress is tangential. It has magnitude also, direction also. But it will not be scalar because it has direction, but it is not vector also, guys. It is actually tensor. Okay, for being vector, for being a quantity to be vector, three things are required. Okay, in NCERT they teach you wrong, it is written wrongly that only two things are required. Three things are required. One is magnitude, which stress also have, either normal stress or shear stress. It should be having direction, which stress also have, either normal stress or shear stress, and it should follow parallelogram law of addition. Okay, parallelogram law of addition it should follow. That is A vector, this is B vector, so this is A plus B vector. So these three things are required for being vector. These three things are required for being vector, guys. Okay, stress has this, but it does not have this. All the three things are required for being vector. Stress has this, but not this. Two stresses like this, you cannot, the summation you cannot write like this. Okay, so this stress does not follow this. So anything which has magnitude and direction but not follow parallelogram law addition is called as tensor. So this is a tensor quantity. Okay, now what are the three types of normal stress, guys? What are the three types of normal stress? See, first one is compressive stress. Okay, like this one, compressing it, kahan gaya? Yeah, this one, compressive stress. Guys, if compression is between same material, it's fine, but if the compression is from different material, that is called bearing stress. Like if this is a column of concrete, but columns are of this, sorry, this beam is of concrete, but columns are of steel, then steel is in compression, but with different material. This beam is of concrete and these columns are of steel. So this compression is due to between two different materials, that is called bearing stress. If all the materials are same, then it will be compression. But if compression is between different materials, it is called bearing stress. And one is bending stress, that is a complete chapter. Okay, one is bending stress, bending normal stress, that is a complete chapter, guys. If you apply a movement like this, I'm not going into detail, it bend like this. So here it is elongating, tension stress. Here it is shortened, it is compressive stress, normal stress. But what is that? Sigma by y, m by I, in that chapter we'll study. So these are the types of normal stress. Shear stress, guys. Shear stress are two types. Okay, one is direct shear stress. One is direct shear stress. Direct shear stress is what I have given you as an example. Directly coming due to force. Direct shear stress is what I have given. This is direct shear stress. Force directly is coming. That is direct shear stress. And one is indirect shear stress. What is indirect shear stress, guys? If suppose this is a circular shaft, in this circular shaft I apply a torque. Torque is nothing, guys. Torque is movement only. Unit is also Newton meter, kilonewton meter. Torque is not something coming from a different planet. It is movement only. Force into distance. The only thing is it is about the longitudinal axis. Any movement about the longitudinal axis is called torque. Okay, this is the longitudinal axis. This is the longitudinal axis. This is the longitudinal axis. Any movement about that is torque. Okay, torque is also a movement. Now, guys, when in this shaft I am applying a torque like this, when in this shaft I am applying a torque like this, see this cross section. See this cross section, guys. Okay, see this cross section. When I am applying a movement like this, when I am applying a movement, I am not compressing it, I am not elongating it. I am not compressing it, I am not elongating it. I am rotating like this only. So in this plane, shear is coming because I am rotating in this plane only, guys. Tangential only, guys. Okay, tangential. I am not compressing this, I am not elongating it. Tangential. But that tangential internal resistance or force is not coming due to force. Like here. Here it is coming due to force. In torque case, when I am doing like this, I am not compressing it, I am not elongating this. In this plane only, due to not force, some other thing, that is indirect shear stress. Okay, give me yes or no, guys. Give me yes or no, everyone on the comment section. Have you understood everything till here? Have you understood everything till here? Okay, now guys, let me do a question, then we'll be going to strain as well. This is 1 and 2. Find the normal stress on the first and second bar. Find the normal stress on first and second. Guys, first of all, this whole body has to be in equilibrium. So this 100 downward, 50 downward, 50 downward. Total 200 downward, 100, 50 and 50. Total 200 downward. So here, total 200 upward. Correct? as it is 50, 50, 100 Newton, 200 Newton downward. So here it is 200 Newton upward. Everyone got it? Okay. Now guys, if I want to find the stress in 1 bar, cut here in 1. Now cutting the stress bar like this, in 1 section, this 100 Newton, okay, 100 Newton, this is the 1 section. So guys, whole body is in equilibrium. Whole body is in equilibrium. Small part is also in equilibrium. So for balancing here, 100 Newton should be coming. So what is the stress in 1? Internal force, that is 100 Newton by area. What is the area? 10. 100 Newton and 10. It is 10 Newton per mm square. 10 Newton per mm square. Okay. And guys, you can see from top also. If the same thing I am making from the top, okay, top I am making, see, this is 1 section. I am making it from top. Okay. Then 50 Newton is coming. Here also 50 Newton is coming. 50, 50. And here 200 is coming above. 200. So now see, whole body is in equilibrium. So small part is also in equilibrium. 50 downward and 200 upward. 50 downward, 200 upward. So net 100 upward is na 200 minus 50 minus 50. 200 upward and downward is only 100. So net 100 upward. So for balancing, 100 downward. Always guys, internal force equal in magnitude and opposite in direction. So both 100, 1 upward, 1 downward, again 100 by area. Now guys, in exam you don't have to do this long thing. Okay, you don't have to do this long thing. What you do, cut a section here. Either see from downward, let us see from bottom. Force is going away, take it positive. Force is going away, take it positive. So see from downward, 100 is going away, take it positive. By area, 10 is equal to 10 Newton per mm square. Directly, you don't have to make these diagrams. Or sigma from top at 1 section. So see from top, 200 upward, going away. You cut a section here, going away. This 100 is also going away, you take in positive now. Cut a section here, I see, this is from bottom. See from top, 200 going away, positive. See from top, this is done, these two are also coming. So 50 and 50 coming inside my hand. So minus 50, minus 50. Okay, see from bottom, only one force, 100 going away is positive. See from top, 3 forces, 1, 2, 3. Going away, positive. These two coming inside, minus. Upon 10. So again 10 Newton per mm square. Either you see by cutting the section from bottom, cutting the section from top, either this shortcut. Now guys, at 2 section, okay, I'm not doing like that now. Sigma 2, so let us see from top. Cut a section here, from top only one force going away. Going away is positive. 200 by area, 20. That is 10 Newton per mm square. Or see from bottom, cut a section in 2 to downward. Downward there are 3 forces, 1, 2, 3. 1, 2, 3, and all 3 are going away from my hand, going away from the section. So all are plus, 50, 50 and 100, 200. Okay, sigma 2 from bottom, all are going away upon 20. Again 10 Newton per mm square. So option number A. Have you got it? Have you got this beautiful explanation, guys? In any way you can do now, na? In any way you can do now, na? Give me yes or no. Come on, come on, come on, come on, everyone. Come on, everyone. Come on, champions. Come on, champions. Have you understood? Okay, the same thing you have to do now here. Okay, homework, comment section. I want answers on the comment section, guys. Now, equality of shear stress. Guys, you take any beam, any loading is applied on that beam. Take a small part from that beam and zoom it. Take a small part. This was a small part. This was a small part. and zoom it. Once you zoom it, it will be something like this. So like I'm only considering shear stresses. Shear is coming like this, shear is coming like this, shear is coming like this. In this phase it is coming like this. All will be equal in magnitude. Sir, how? How, sir, I believe you that all are equal in magnitude, sir? How I believe, sir, that all are equal in magnitude? How to believe? Let me tell you how to believe. I am doing derivation now. I am doing derivation now. See, everyone, this is a body. Okay, shear is coming like this, like this, like this, like this. Okay, this is suppose tau 1, this is suppose tau 2, this is suppose tau 3, this is suppose tau 4, and actually the body is like this. This is A, this is B, and this height is C. So tau 1 is acting at top face, tau 2 is acting at this face. Shear, all are shear. This is tau 1, this is tau 2, shear. Tau 3 is acting at the bottom face, tau 3 is acting here, and tau 4 is acting here. All are shear. Okay, all are shear. All are shear. Let me explain you here. This is A, this is B, this height is C. Okay, so tau 1 is acting at the top surface, shear stress. Tau 2 is acting at the rightmost surface, tau 2. This is bottom. In bottom, tau 3 is acting like this, and here tau 4 is acting at the leftmost face. Now you got it. I am saying all are equal. How? How, sir, you can say? Okay, guys, in strength of material we study equilibrium bodies. Okay, so summation of Fx is equal to 0 for equilibrium. Fx which are causing force in x direction. This is x direction. Horizontal I am saying x and vertical I am saying as y. Tau 1. So tau 1 stress. What is force? Stress into area. These are only in the x direction, na? These are not in x directions. These are in x direction. Tau 1 in which area? A into B. This is A, this is B. So this is force right hand side, and left hand side force is stress into area. Stress into area is force, na? Stress into area is force, stress into area is force. So from here tau 1 equal to tau 3. From here tau 1 equal to tau 3. Similarly, guys, summation Fy is equal to 0. So upward force, tau 4 direction will be like this. Tau 4 direction is like this. Y direction is like this, let me tell you, because tau 2 is upward, na? In which area? B into C. So it has to be downward, na, for balancing. Tau 4 acting in B into C. So tau 2 is equal to tau 4. If this is downward, then this is upward. If this is right, this is left. If this is right, this will be left for equilibrium. If this is downward, it has to be upward for equilibrium. If this is upward, then it is downward. So guys, this tau 1 and tau 3 are opposite faces. See, 1 and 3, and 2 and 4 are opposite faces. So if someone says you that opposite phase stress are equal due to opposite phase, this comes in fill in the blanks. Opposite phase shear stress are equal due to which equilibrium? Are equal due to force equilibrium. Due to force equilibrium, guys. Opposite phase shear stress is equal due to force equilibrium. Sir, but you just have proved till now that 1 and 3 are equal. 2 and 4 are equal. You have not proved that all are equal. 1 should be equal to 3 and 2 should be equal to 4. Okay, sir, I am proving all are equal. Now, guys, for equilibrium, not only force, but summation of movement about any, suppose this point, O has to be 0. Not only force, the movement has to be 0, na? not only force, the movement has to be zero, na? Give me yes or no. Not only force, the movement also has to be zero, na? Give me yes or no, please. Okay, sir. Stress sign convention, I'll tell you, don't worry. So 3 and 4 are passing from that point. Movement is force into distance, so they are passing from that point, so it will be 0. Tau 1, which force? Tau 1 acting on area A into B. This is stress into area. Stress into area is force. Movement will be distance. So from O, what is the distance? C. So this is clockwise. Tau 1 is about O point clockwise. Now this tau 2 will be anti-clockwise. So tau 2 acting on B into C. B and C. This is force. Stress into area is force. And distance from O point is A. So tau 1 equal to tau 2. Similarly, tau 1 equal to tau 3 equal to tau 4. They are adjacent phase. So adjacent phase shear stress are equal due to adjacent phase shear stress are equal due to, tell me in the comment box. Shear stress are equal due to which equilibrium? Due to movement equilibrium. This is asked in fill in the blanks, guys. That opposite phase stress are equal due to force equilibrium, adjacent are equal to movement equilibrium. Now tau 1 equal to tau 3, tau 3 equal to tau 4, and tau 4 equal to tau 2. That means tau 1 equal to tau 2 equal to tau 3 equal to tau 4. Sign convention I am coming. And I will name them as 1 tau. So now from now onwards I have never used SOM like 1, 2, 3, 4. How I will make? I will make like this. I make only 1 tau. If 1 is tau, then all are tau. If 1 is tau, then all are tau. So either this or like this. If this is not right, this is left. So this has to be right. Okay. And if this is not bottom, this is top, then this is to be like this. So either head to head is meeting or tail to tail is meeting. Head to head is meeting or tail to tail is meeting. Although I'll tell you a better scientific way of sign convention, but till then you can see this is positive, this is negative. Okay, and sigma, tension stress is positive, compression is negative. Although I'll tell you one more way of sign convention. Got it? Give me yes or no. Give me yes or no, everyone. Okay. Now guys, one more thing, that pressure is force upon area and stress is also force upon area. What is the difference? What is the difference? Pressure is force by area, stress is force by area. What is the difference, guys? The difference is, guys, pressure is external perpendicular force by area. Okay, actually the pressure is external perpendicular force by area and stress is internal. If someone is telling you that tomorrow is your exam, your parents, your girlfriend, your father, your mother, your neighbors, your teacher, your cousins, your brother, your sister, everyone, externally, exam, tomorrow is exam, that is pressure on you. But nobody is telling you, your parents, your cousins, your father, mother, sister, no one is telling you. Nobody is telling you that tomorrow exams, you internally having, kal exam and tomorrow exam, that is stress. So external perpendicular force by area is pressure and internal force by area is stress. Okay. Now, everyone, please see this. This direction is x direction. This direction is y direction. This direction is z direction. Now you take a very small element. Okay. Now guys, any face I name as the x face. Any face I name as the x face. If normal from that, if outward normal, not normal, normal can be in both sides. If outward normal is in x direction, if outward normal is in x direction, okay. Similarly, any face name will be y face if outward normal is y direction. Any face name will be z face if outward normal is in Z direction. Got it, everyone? Got it, everyone? Please tell me. Any doubt? Okay. Now see. अच्छा कहाँ गए? हाँ. So what is this phase? If this is x direction, this is y. This outward normal is in which direction? X direction, na? So this is x phase, na? Outward normal is in x direction. Outward, not inward. Outward normal is in x direction. This is x phase. What is the name of this phase? What is the name of this phase, guys? Tell me. What is the name of this phase? Everyone on the comment section. What is the name of this phase? The outward normal is in y direction. So this is y phase. And what is this phase? Outward normal is in z direction. So this is z phase. Correct? Correct? Now guys, this stress is normal. So it will be sigma. On which phase? X phase and in x axis. This is how I am representing the stresses on a body. This is, first letter is the name of the phase and second is the direction. Sigma, because it is normal stress in x phase in x direction. Now this is shear. On this green plane it is shear, tangential. In which phase? In x phase. In which direction? Y direction. This is how I represent the stresses. This is also tangential, so shear. In which phase? In x phase. In which direction? That is z direction. This is z direction. Outward normal is in z direction. Got it? Now this one, this is normal in y phase. This is y phase in y direction. Okay. This one is shear on y phase in x direction. This is shear on y phase in z direction. दिख रहा है क्या? Is it visible? Is it visible? Is it clearly visible? Yes or no? Yes or no? Okay, it's fine. Okay. Similarly, in this is normal. So sigma in z phase in z direction. Okay. This is normal sigma in z phase in z direction. This is shear. This is shear in z phase in y direction. This is also shear in red phase. This is also tangential in z phase in x direction. This is the most general case of loading where everything is coming. Where everything is coming. Most general case of loading. Okay, so total elements how many? Total, if somebody asks you in general case, how many elements? 9 elements. Total 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 elements. And total distinct how many? Total elements in general case are 9. Distinct are only 6. This is, guys, in most general case, 3D case, everything is coming. In every direction normal stress, in every direction shear stress is coming. When everything is happening, then this is the case. In every direction normal stress is coming, in every direction shear stress is coming. Then this is the case. So total are 9 in general case loading. If you are saying, sir, what about negative x phase, that backward phase? What is the bottom phase? Guys, for equilibrium it has to be same. Now whatever in this phase, at the bottom phase it has to be same. Now guys, adjacent shear stress are equal na, due to moment equilibrium. This and this has to be equal na. If this is more than this, then it will be a clockwise orientation of this block. So this and this has to be same. Similarly guys, this and this has to be same. If suppose this and this is not same, this is more, then this will be a movement like this. This will be a movement like this, it will topple there. So here movement and this movement has to be balanced for equilibrium. Similarly guys, this and this has to be same. If suppose that tau zx is smaller and tau xz is more, it will rotate like this, it will rotate like this, it will rotate like this. So out of 9, I of these two only one is required, of these two only one is required, of these two only one is required. So 1, 2, 3, out of this only one is required, 4, out of this only one is required, 5, out of this only one is required. So distinct are 6 and total are 9. Everybody on the comment box give me yes or no. Everybody on the comment box give me yes or no. Everybody on the comment section give me yes or no. Please. Got it? Got it? Okay. So this is how I represent all the 9 elements. In a stress tensor, all 9 in a general case loading, this is how I represent. Now guys, stress is tensor. How many order tensor? So finding the order, now what you have to write the formula, 3 की power x is equal to number of elements in 3D case. Number of elements, total elements in 3D case, not 2D case. So whatever the x value will be coming now, that will be order of tensor. So total number of elements in general case is 9. So x is equal to 2 is equal to order of stress tensor. Order of stress tensor. Order of stress tensor. Got it? Now guys, see this. This is a diagonal. About this diagonal, this matrix is a mirror image, na? About this diagonal, please see, this matrix is a mirror image, na? Because tau xy and tau yx has to be same. I just told you here. Tau xy and yx has to be same. Okay, similarly, tau xz and tau zx has to be same. Tau zx and xz has to be same. Similarly, tau yz and tau zy has to be same. So this is mirror image. This mirror image is due to movement equilibrium. Due to movement equilibrium, because xy and yx are adjacent faces. Adjacent faces stress are equal due to movement equilibrium. xz and zx, xz and zx are equal due to movement equilibrium. Give me yes or no. Give me yes or no. क्या लिख रहा है भाई? Reflex 8055. No sir, it is water image. You are oh my god. Oh my god. इसको लग रहा है कि 2 कमरे की कोचिंग चला रहे हैं हम, और ऐसे कमेंट्स का हम नज़रअंदाज कर देंगे. कर भी देते, इसको नहीं करेंगे लेकिन. ओके, एक काम करो, इसका वाला फॉर्म करवा दो. आईपी एड्रेस साइबर क्राइम को रिपोर्ट कर दो, अभी कर दो. रिफ्लेक्स 8055 फॉर योर काइंड इंफॉर्मेशन. In Byjus, parallelly right now, more than 95 classes are going on, and these kind of comments are very common for us. Very common. You are thinking that 2% have started the coaching and they are doing everything, but for these kind of comments we have a special already automated program where we have to copy that link and you have to report cybercrime. 99.99% cases we don't do such things, but you are comes under 0.01% case. So someone will call you. Okay, someone will call you tomorrow from the nearest branch of cyber, and what will happen after that you can tell me. Okay, no apologies. Okay, please, I have done this earlier also, and many students are then doing this and mailing me hundreds of times and thousands of times on Telegram. I have done this, so take care of this. Okay. Okay. Now water image, my brother, देख लेना अपना, ठीक है. वो वाटर उनके लिए वो 2 मिनट का काम होता है, आईपी एड्रेस से बिल से पता कराना कि कहाँ का एड्रेस है. चलो ये वाला आपने कर लिया था. अच्छा, नाउ साइन कन्वेंशन. नाउ साइन कन्वेंशन. नहीं कर दो एंटर दबाओ, कर दो रिपोर्ट कर दो. अभी ब्लॉक मत करो इसको, ब्लॉक मत करो. हाँ रिपोर्ट कर दो. हाँ ठीक है. कल छुट्टी तो नहीं है, सैटरडे संडे. ठीक, कल ही आ जाएगा प्रेफ्लिक्स आपके पास. ठीक है, चलो. ओके सी, मेरे को लोकेशन बता देना है ना, एड्रेस भी. हाँ ठीक. सी, नाउ साइन कन्वेंशन. Guys, if in positive phase and positive direction, I will tell you what I am writing, it will be positive. Negative phase in negative direction, it is positive. Positive phase negative direction, it is negative. Negative phase positive direction, it is negative. What is this? You have not understood because I have not explained you. What is this? You have not understood because I have not explained you. Okay, see, this is x direction, this is positive y direction, this is positive x, this is positive z. Now please tell me, everyone, on the comment box quickly, what is this phase? What is this phase? What is the name of this phase? What is the name of this phase? Tell me on the comment box, guys. Come on. What is the name of this phase? X phase. Positive is, and name is given to the outward normal, that is in x direction. So this is x phase. What is the name of this phase? What is the name of this phase? Outward normal is going in negative x direction. So this is negative x phase. This is negative x phase. Okay. Now, what is the name of this phase? Outward normal is going in positive y direction. Positive y. So this is positive y phase. What is this phase? Outward normal is going in negative y direction. So this is negative y phase. Similarly, guys, this is z phase and backward will be negative z phase. Okay. Okay. Now what I have written here, guys, suppose I want to know the sign convention of this. So this is in positive phase, positive x phase and positive y direction. So this will be positive because it is in positive phase, positive x phase and positive direction. Now I want to know the sign convention of this. This is in positive y phase and in positive x direction. So this is also positive. Suppose, guys, I want to know the sign convention of this. This is in negative x phase, negative phase and in negative y direction. So this is also positive. Suppose I want to know sign convention of this shear. This is negative y phase in negative x direction. So this is also positive. Suppose I want to know the sign convention of this. This is in positive x phase in positive x direction. So this is positive. Suppose I want to know the sign convention of this. This is in positive y phase. The top face is positive phase in negative y direction. In positive y phase negative, positive phase negative direction. This is negative. Now suppose this one. This is a negative x phase in positive x direction. So this is negative. So this is one way. Otherwise, guys, from here you will get the same results. You can take a simpler one where I have made that simpler one. you always this positive, this is negative. This also have derived from there only, that thing. Okay, tension positive, compression negative for normal stress, and for shear stress this is positive, this is negative. Either you do this, from this concept also you will get the same result, from this concept also you will get the same result. Okay, okay guys. रिफ्लेक्स, अभी कुछ भी कहना हो ना, मैंने उस बंदे को कह दिया जो हमारा ऑफिस में बंदा बैठता है, उसने एंटर दबा दिया, कल एक बंदा आ जाएगा या नहीं भी आएगा, आपका मोबाइल हो सकता है किसी और एड्रेस का, वो वहां पूछेगा, फिर वहां से आगे पूछेगा, वो आप पे आ जाएगा कल नहीं तो परसों। सैटरडे संडे के दिन कभी कभी मंडे हो जाता है, सैटरडे संडे के दिन कभी कभी मंडे हो जाता है, पर अभी कल सैटरडे संडे नहीं है, तो आपको वो बंदा कल या परसों तक पहुंच जाएगा। 99.99% केसेस में हम ऐसा नहीं करते, इग्नोर कर देते हैं, ब्लॉक कर देते हैं। आपको मैंने ब्लॉक नहीं किया, ब्लॉक करके दिखाऊं आपको, अभी ब्लॉक नहीं किया मैंने आपको, मैंने वहां करवा दिया काम। कुछ भी एक्सप्लेनेशन देना हो, मेरे मेल आईडी abhinav.negi@byjus.com में एक्सप्लेनेशन दे देना, और अपना फ़ोन नंबर भी मेरे को दे देना, ठीक है। उसके बाद मैं देख लूँगा, एंटर वहाँ से सबमिट हो चुका है तो कार्रवाई तो होगी, अब वो कहाँ तक जाती है वो देख लेंगे, ठीक है। अब वो डिलीट आपने किए, इसको बेस्ट टीचर किए, उसको मजाक लग रहा है। यहाँ पे लोगों को लगता है 2 कमरे को कोचिंग चला दिया, 4 टीचर पढ़ा रहे हैं, तो पीछे का सपोर्ट सिस्टम होगा ही नहीं। अब उनको ये नहीं पता है कि किसी भी ऑर्गेनाइजेशन में कैमरे के आगे एक लोग पढ़ा रहा है तो पीछे कम से कम 150 लोग काम कर रहे हैं। बायजूस में अगर टोटल अभी 4000 टीचर हैं तो 50,000 से ज़्यादा लोग पीछे काम कर रहे हैं, ठीक है। तो अब मेल में कर देना, अब जो इसका तो कुछ नहीं, इसको ब्लॉक भी कर देते हैं अब, है ना। अब इसको ब्लॉक भी कर देते हैं। चलो, चलो, एवरीवन गॉट इट? Vipin, Kanakati, everyone guys, sorry, your studies are disturbed because of him. Leave. Got it? Okay. Now guys, the same matrix if I want in 2D. In 2D z direction will not be there na. So sigma xx, tau xy, z is, what is z? I don't know. In 2D, what is z? We don't know. Tau yx and sigma yy. In 2D, how many total number of elements? Total are 4 and distinct are only 2. Sorry, distinct are only 3. Because one is, this should be known, this should be known, but out of these two, only one is required. Out of these two, only one is required because both of them will be equal due to moment equilibrium. Okay, so this is about stress. Tell me this. Tell me this, please. Everyone. Okay, कहाँ गया? हाँ. So guys, in 2D, how I write? Sigma xx, tau xy, tau yx, and sigma yy. Tell me the answers. Now sigma xx is tension, positive. So this will be 20, positive. Sigma yy is this one, that is 50, compression. Compression is minus 50. And this kind of shear, I told you guys, this kind of shear is positive and this kind of shear is negative. So this one is negative shear. Okay, so these values are negative. How much shear? Minus 40. Shear are all equal. So which is coming? B option. Which is coming? B option. Got it? Got it? Okay. Now guys, strain, it is represented by Greek letter epsilon. normal strain. Guys, as in strength of materials, we are studying about the deformable physics. So here length will be changed, dimensions will be increased or decreased, or orientation will be changing. Okay, now guys, when we apply the force on a body, okay, when we apply, this is the thing, and when we apply force on a body, as in strength of material, we are dealing with deformable physics. So here guys, there will be deformation, might be very small, not visible by our naked eyes, but very small, but there will be. So that's normal strain epsilon. There are two types of strain, guys. Normal strain represented by epsilon, and shear strain represented by gamma or phi. So normal strain is change in length by original length. Those who know about true strain will study later on. By default, if strain is word is used, that is engineering strain. Engineering strain is delta, change in length, upon original length. Guys, what will be the dimension of this? Kilometers, meters, or micrometers? Tell me in the comment box. What will be the dimensions of this strain? What will be the dimensions of the strain? Meters, kilometers, micrometers, what? Guys, the dimensions will be unitless. It is represented in ratio. This is length unit, this is a length unit. So both will be cancelled. So it is represented in ratio or percentage. Guys, mostly the questions are coming not from strain but from stress. Okay, but practically in originality, guys, there is no device in this world which can measure the stress. Okay, stress can be calculated, force by area, but no device can measure the stress. Okay, suppose in this smart board I am applying some force, so some stress will be coming. So there is no device, you put it here and it will give you stress value. No, but strain value can be measured by strain gauge. Let me tell you a basic rough principle of strain gauge. Strain gauge is a device like this, okay, where the wires are wounded and it are attached to a volt. Okay, so V is equal to IR. Now resistance is equal to rho into L by A. This is not of civil engineering, this is electrical engineering. So by strain, length will change. So length will change, so R will change. So R will be changing something. So for a constant voltage, I will be changing because R is changed. So now the computer science engineers, you give 10 rupees and make a coding. So they make a coding that this much is R change, so this much is strain. This much is R change, this is the strain. This much is current change, so this is strain. This much is current change, this is strain. Why current is changing? Because resistance is changing, and for the same voltage, if resistance change, current will also change. Okay, not for civil engineers, guys. So there is a device, strain gauge, from which we can measure strain. Stress cannot be measured, can only be calculated. Okay, this is normal strain. Epsilon. Shear strain is represented by gamma or phi. What is shear strain? As we are studying deformable physics, so like this kind of stress, angle will change. Earlier the angle is 90. Now the angle will be 90 minus something, gamma or phi. Here the angle may be increasing as well. Similarly, here will be change. So what is change? Earlier the angle is 90, now it is changes by gamma. So gamma is shear strain. Gamma is shear strain. And this will be, if total change is gamma, so this will be 0.5 gamma change, this will be 0.5 gamma change. Sir, how? If total change is gamma, how you can say that here is 0.5 gamma change and here is 0.5 gamma change? How you can say this? Sir, I can say this because there is 0.5 gamma change and 0.5 gamma change because all shear stress are equal. So if all shear stress are equal, then guys, the change here, and if total change is gamma, then the change here and here is 0.5 gamma. Now sir, sign convention. If it is tensile elongation, it is positive. If it is elongation, it is positive. If it is shortened, it is negative. Guys, shear strain has also a very complex sign convention. Positive phase, positive, and positive phase angle is increasing, so it will be negative shear strain, and very complex. Let me tell you very simple. This was a positive shear stress, And this was a negative shear stress. So positive shear stress, whatever is the strain, either angle decreasing, increasing, it will be positive strain. And negative shear stress will produce negative shear strain. Okay, so this will be do later on some other class. Okay, so guys, about some weightage, books. What is the weightage? What is the books? How to study? What are the big subtopics? What are the small topics? Okay, that we have discussed yesterday. I have shared the PDF in my Telegram group also. You can refer that. Okay, and this I'll be coming tomorrow. This I will be coming tomorrow, guys. Okay, this is today. Tomorrow I'll be coming. Tomorrow 9 PM I'll coming with deformation chapter. Deformation of stress and strain. How much is the change in length? Okay, you can find me in my Telegram group, Civil by Abhinav sir. Okay, you can join me there. Okay, and guys, as I already told you, the vision courses are complete course in English and Hindi both. Okay, these courses you can, where we are teaching from zero level, guys. Complete course, English and Hindi both are available. And if you want to know anything about this fees or any plan, either you can connect here or in the description box there is a form, you can fill that form. Okay, and now guys, this is done. Tomorrow I'll be doing this deformation of bar tomorrow. Okay, and for mechanical also same class, na? Then guys, Dheeraj sir will be taking stress strain diagram and properties of material. So let us see tomorrow. I hope you enjoyed, guys. I hope you enjoyed the session. Please tell me. I'm just sharing the this PDF in my Telegram group, that is Civil by Abhinav sir. Okay, I hope you enjoyed, guys. Thank you. Thank you, guys. See you tomorrow at 9 PM. Thank you all. Take care.